In question 5 here, we want to draw up tan of x. Now we know what tan of x looks like, so it has the asymptotes, and it has that shape, and it keeps having an period of pi. 1 minus x, so if we draw up 1 minus x, it would go through 1, and it has a gradient of minus 1, so it goes through the curve there. The number of roots of the equation tan x equals 1 minus x. Now, if we don't dictate our domain here, technically they will have an infinite number of roots because the nature of the curves, they both keep going on forever. But between minus 2 pi and 2 pi, the curve, it actually doesn't come out here, but they're going to intersect there. So that's 1, there's 2, there's 3, 4, and 5. So there's 5 roots of this function, these two functions being equal to each other. And again, if it wasn't between minus 2 pi and 2 pi, we'd be going on for an infinite number of roots. Now, using the two curves here, if we use cos x and sin x, use those to draw sin x plus cos x. So the idea here, the blue one is the sin x, and the red one is cos x. So we see what they look like here. What we want to do is add the two y values at all different times and see what we get. So we have a look, we start at the origin. At the origin, sin x is equal to 0, cos x is equal to 1. So that's why it's at 1. We keep going up. The maximum value of this curve will be at pi on 4, where they both equal 1 on root 2. So that's actually 2 on root 2. Again, where cos starts to be equal to 0, sin x is equal to 1. So that's why it's back at 1 there. And then both curves are decreasing. So at the particular point here, and it's 3 pi on 4, they're actually going to be the same size but opposite in sign. So that's why it's at 0. So pi on 4 was 1, it's at 2 on root 2, its maximum value, but then at 3 pi on 4, it's at 0. So they keep going down, the y values start to be negative. Again, sin x is back at 0, so that's why it's going to be at minus 1. And then at 5 pi on 4, they're both equal to minus 1 on root 2. So it's going to be minus 2 on root 2. And then the curves start to go up again because cos x is already on its way back up. It's at 0, so it's back at minus 1. And then at 2 pi again, we're starting again. Okay, so that's how we get sin x plus cos x, by looking at the y values of the two curves separately, adding them together and getting those critical points and getting that shape of the curve.